right, solving equations, A5. All right, mathletes. Here we're talking about solving equations, and we're not just going to be doing linear equations like we have here that you should be familiar with from Algebra 1 and geometry type stuff, but we're going to get into quadratics, rational functions, and eventually into radical type functions. Notice we usually refer to different sides of the equation, left side being left of the equal side, and right side being to the right of your equal sign. So we'll refer to sides. When we're trying to find solutions for these, sometimes they're also called roots when we're solving these equations. All right, so let's go look at our first example here. First example is solving this rational equation. My first strategy on this one is I want to get common denominators with my rational equations. Once I have common denominators, I can combine like terms, divide them out, multiply things out, and such like that. So I'm going to deal with the left side here first, and I want to get 5 with the same denominator over here. So I want to multiply that term, 5, by a unique formula of 1, so I get a common denominator. I'm going to choose y over y. So I get 4 minus 5y over y, which is equal to 5 over 2y. At this point, I notice that I have rational equations, and I can multiply out by my denominator. So I'm going to multiply this side on the left. I want the y to cancel, so I'm going to multiply by y over 1. What do I do to this side? I got to do to this side. And in this step, I'm going to do it twice because I want to multiply by 2y on this side to get rid of the denominator here. So then I got to do that over here, 2y over 1. Much of this simplifies out because something divided by itself is 1. Something divided by itself is 1. But what am I left with? Over on the left side, I have 2y times the quantity 4 minus 5y is equal to 5y. Well, now I have this expression, and in order to solve it, I can't isolate a single y because I have a bunch of them. So I'm going to distribute this through and see what happens. So I get 8y minus 10y squared equals 5y. At this point, I notice I have a quadratic. No matter what I do, I can't add and subtract y's to a y squared, so I'm going to have to resolve to solving this by factoring, and we'll learn some other strategies, and you should have learned some other strategies in Algebra 1, and we'll do those as well. But here I'm going to try and factor. So to factor, I always want to get one side equal to 0. So in order to do so, I'm going to subtract 5y here, subtract 5y on this side, and what I am left with is 3y minus 10y squared is equal to 0. So now I can factor, and I can factor out the left side. Both have a y, so I have y times the quantity 3 minus 10y is equal to 0. So here we're going to use our zero product property. If I have two things being multiplied by each other to equal to 0, so let's say if I have A times B equal to 0, either A is equal to 0 or B is equal to 0. It's the only way that this equation can be true. So as I look at this, here I either have to have y equal to 0 or I have to have 3 minus 10y equal to 0. Well, the first one is already simplified. Y could be 0, or I must simplify this one. So in order to do so, I want y by itself, so I get minus 3, negative 10y is equal to negative 3, divide by a negative 10, divide by a negative 10, and I get y is equal to 3/10. Well, I'm not done yet. I have to check my answers because I can come up with an extraneous solution. Well, notice if y equals 0 and I plug it back into my original equation, let's clear it up here, I would have 4 divided by 0. Well, if I have 4 divided by 0, that is undefined, and that is not a possible solution. Again, I'd have a 0 over here. I can't ever have 0 into my solution, so this is not going to work in my solution set. So to check to see if 3/10 is a solution, I'm going to go ahead and try and save some room here and plug it in. Okay, so if y is equal to 10, or y is equal to 3/10, we would have 4 over 3/10 minus 5 is equal to 5 over 2 times the quantity of 3/10. I don't know this is equal, so I'm going to put a question mark there to justify this. So let's simplify the left side, then simplify the right side, and see if they're equal. So here I have a compound fraction, so I remember dividing by something. So 4 divided by 3/10 is the same thing as multiplying by the reciprocal, 10/3, minus 5. Okay, well then I'm going to get, this is like 4 over 1, I get 40 over 3 minus 5. Well, in order to subtract things, I need a common denominator, so I'm going to multiply this by a form of 1, 3 over 3, and I get 40 over 3 is minus 15 over 3, simplifies to 25 over 3. So that's my left side. So in order to see if this is equal, I need to simplify and see if the right side is 25 over 3. So first step, I'm going to simplify my denominator, 5 over 2 over 1. So I get 5 over 6 over 10, compound fraction. So copy, dividing by something is the same thing as multiplying. Flip it, the reciprocal. Right? Reciprocal is your math term for flipping. So this is like 5 over 1. So I get 50 over 6. They're both divisible by 2. So I get 25 over 3. Yes, they are equal. I've checked that solution. So yes, y equals 3/10 is a valid solution for this problem. All right, let's do one more here for a rational equation. All right, so one strategy again is to get a common denominator. So in order to identify how to get the common denominator, I want to factor out a quadratic and see if it's prime. So I'm going to recognize I want things to multiply to 3 and add to -2. So I want -3 and 1. So as I simplify this, I get 4 over x minus 3 is equal to 2 over x plus 1 plus 16, and I factor this is x plus 1, x minus 3. All right, so I should notice that I have some things that are similar. Here, x minus 3, there, x minus 3, here, x plus 1, here x plus 1. So in order to get a common denominator, I want things to match this one over here, because I don't need to add anything to that. So for my left side of the equation, I need this x plus 1 in the green, and I'm going to multiply this by 1, so I don't change the value, x plus 1 times x plus 1. Okay. Then on the right side, the first term there, I don't have an x minus 3 there, so I'm going to multiply this by the quantity x minus 3 over x minus 3, which is 1, but it's going to give us our common denominator that we need. So as I simplify this, I get 4 times the quantity x plus 1 over x minus 3 times x plus 1 equals 2 times the quantity x minus 3 over x plus 1 x minus 3 plus 16 over x plus 1 x minus 3. All right, so notice we have a common denominator through each term. So when we ever have a common denominator through all of them, multiply both sides by the denominator, x plus 1 times x plus 3 x plus 1 times x plus 3. And when I do so, things are going to cancel out. This here, x3, or I'm sorry, I think, see, it should be x minus 3. X minus 3 as I had on the denominators. These will cancel out. So what do I have in the x plus 1? Cancels out, and my denominators are gone. So what am I left with? Left with my numerators. So I have 4 times x plus 1 equals 2 times x minus 3 plus 16. All right, so I'm going to distribute 4x plus 4 equals 2x minus 6 plus 16. I have no squared terms, so this is a linear equation. I should just be able to solve this by collecting like terms. So I'm going to get all my x's on the left and all my constants on the right. So I'm going to minus 2x, minus 4, minus 4. So I get 2x is equal to negative 10 plus 16 is 6, so x must be equal to 3. Well, again, I got to plug it in. Well, I have a big problem here. I plug in 3 here, right? I'm going to get 4 over 3 minus 3, which is equal to 4 over 0, which is undefined. It's a big no-no. So that cannot be a solution. So there's no solution to this equation. So we would just say no solution. A lot of work to show there's no solution. Another way we can look at this is graphically, why there might not be a solution. So I put my two equations, 4 over x minus 3, that was my left side, and then I put below here 2 divided by x plus 1 plus 16 divided by x squared minus 2x minus 3. Notice, when I graph these, okay, they don't actually intersect. So if you notice, this 4 over x minus 3 is this equation, this rational function that's there, and it's this one that's here. And my blue equation, this one, okay, is right here. Remember, these will go on for infinity. And the one's right here. So although these two parts of it look like they get very close to each other, as we keep going down into infinity, they get closer and closer, but they'll never touch, because these rational functions, as you would have graphed some of them in Algebra 2, you know they have an asymptote because it's undefined at x equals 3, or in this context 3. we are never going to have a solution or a point where these two equations are going to intersect.